Hello everyone, welcome to the channel. This video is about the most widely used types of learnings in machine learning. This video covers basics of data labeling, 14 types of learnings in machine learning, and most widely used machine learning algorithms, supervised learning, unsupervised learning, semi-supervised learning, and self-supervised learning. We know that we need data to train a machine learning model. Data is oil for machine learning models. The machine learning algorithms work on data. So before understanding the machine learning algorithms, it is necessary to understand the input to the machine learning algorithms, that is data. What is the source of data to ML training, and how data is transformed so that machines can understand the data. Firstly, where does this data come from? The data could be from internet, data could be from sources like MNIST data, IMDb data, data could be from IoT sensors, data could be from camera feeds, social media feeds, data could be synthetic data. All this data from different sources is raw data. What is raw data? Raw data is direct from the source without any structure. So we need to give structure to the raw data so that machines can process the data and predict the output. Raw data can be transformed into unlabeled data by providing basic structure to the data without specific tags. This unlabeled data can be refined and can be converted to labeled data set. Labeled data requires more effort as data must be assigned with specific tags. Hence, labeling needs significant effort. Labeling can be on images to identify the objects in the images, that is in computer vision. Labeling can be on text to identify parts of speech, intent. Labeling can be on audio to identify noise of birds, sound alarms. For audio labeling, first step is transcribing audio into written text and then proceed with machine learning pipeline. Let's say we are developing ML model to identify the objects called vehicles in transport system and classify them into two-wheelers, four-wheelers. First step is to gather data related to transport systems, that is raw data. Then classify the data into groups, clusters, four-wheeler, two-wheeler without specific tags. Then add specific tags to the vehicles. That is, label the data as cars, electric cars, SUVs, sports cars, etc. Why label data? The machine learning models uses these labels to learn patterns in a process called model training. The result is a trained model used to make predictions on new data. Who labels the data? Labeling can be manual or automated. Labeling is done by humans by asking questions like whether a photo contains a car or not, whether a picture contains a dog or a cat. Sometimes labeling is also done by AI assistants. There are 14 types of machine learning algorithms. Some of these use raw data, some of the algorithms use unlabeled data, and some uses labeled data. Which machine learning algorithm uses labeled data? Which machine learning algorithm uses unlabeled data? The unlabeled data is used to train ML models which are based on unsupervised learning. The labeled data is used in supervised learning. As labeled data is clean and classified, why not use the labeled data itself in training AI model? Why do we need unlabeled data? Answer is time and cost. The cost of labeling data is high. Labeling data is time consuming as data labeling is manual effort. Though there are many AI tools to label the data labeled by tools need to be reviewed manually by humans for accurate predictions by AI or ML models. A software developer working on machine learning problem statement can decide whether to use unlabeled data as input to ML algorithms or use labeled data as input to ML algorithms. Moving on to the next slide. There are 14 types of machine learning algorithms. Some of these ML algorithms use unlabeled data and some use labeled data, and some algorithms work on both labeled and unlabeled data. The 14 types of ML algorithms are broadly classified into 4 categories. The first category learnings for specific fields. In this we have supervised, unsupervised and reinforcement. Next is hybrid. In hybrid learning, we have semi-supervised and self-supervised. In this video, we'll look into the details of ML algorithms highlighted in green color. For details on reinforcement learning, please watch my video on reinforcement learning RL and reinforcement learning RLHF, human feedback. Next type of machine learning is based on statistical inference. Inductive, deductive, transductive algorithms uses evidence to determine the outcome. They can go from specifics to general evidence or general to specific evidence to reach the outcomes. Next type of learnings are based on learning techniques. Multitask, active learning, online learning, transfer learning and ensemble learning. These learning techniques are used to learn more from less data to save time and cost of training AI models. Moving on to the next slide. The most popular ML algorithms are supervised, unsupervised, semi-supervised and self-supervised. Let us understand what are these semi and self-supervised algorithms and their purpose. In one of the previous slides, we saw what is unsupervised learning. Unsupervised learning has unlabeled data. Input data is not labeled and data does not have any input tags and has no specific target output. This algorithm has input but no corresponding output. So when to use unlabeled data or unsupervised learning? We may not have large amounts of labeled data or we quickly want to perform an experiment on a set of data. In those cases, we opt for unsupervised learning. Unsupervised learning is an algorithm whose input is unlabeled data and it does not have any specific target output. Algorithms learn on their own and present interesting structures in the data as output. Unsupervised learning tries to discover the groups of similar data sets. Then question is, how to group data? Let us look at an example of unsupervised learning. Let's say we have 1 million customer reviews from an online shopping store for a product. Let's say the product is study table. Unsupervised learning understands the structures and the customer review comments data. Then unsupervised algorithm divides the big cluster into small clusters based on customer review comments. Cluster 1. Like the product study table. Cluster 2. Did not like the product. Cluster 3 is unsure about the product. So, unsupervised algorithm continues recommending similar study table and other products from the company and similar company brands with the same price range to cluster 1. Unsupervised learning finds structures like customer segmentation based on customer buying pattern. Next slide. Let us understand supervised learning. This is an algorithm whose input is a set of labeled data and output is labeled predictions depending on model training. For examples, emails can be classified as spam, non-spam. Supervised learning algorithms can predict the price of the house based on the area of the house, amenities, locality. In supervised learning, in general, data is structured in the form of rows and columns in a table form. The rows and the columns have titles and headings labeled. As we saw previous slides of data labeling, we have a category vehicle in transport system. Unsupervised learning identifies the broad category of transport vehicles as two-wheeler, four-wheelers, by road, by air and by water. Supervised learning identifies specific category like cars from four-wheelers. In supervised learning, for every car image, there must be an input labeled car. For every dog image, there must be an image labeled dog. Based on today's stock market, supervised learning can predict tomorrow's stock price. The price might go up, down, or remain same. Next slide. Next type of learning in machine learning is hybrid learning, that is semi-supervised learning. In this we have mixed data sets, that is small amount of data which is labeled and large amount of data which is unlabeled data. Semi-supervised can be considered as an intermediate between supervised and unsupervised learnings. Semi-supervised learning makes use of all the available data, that is both labeled and unlabeled data, to solve a problem statement, meaning if the data set has a very few labeled examples and a large amount of unlabeled examples, then semi-supervised learning makes use of all the available data to make accurate predictions. For example, semi-supervised learning is used in medical analysis to diagnose a disease where there is limited labeled data during initial phase of a disease. Like during initial phase of COVID-19, there is limited data set to identify the different variants of COVID-19. Some more examples. We have vehicle data set. A few are labeled as car. The rest of the items in the data set are unlabeled. Semi-supervised learns from the labeled data set of two-wheeler, four-wheeler and labels the other items in the unlabeled data set. Another example. In your mobile device gallery, you have pictures of your family and members. Their pictures are captured on occasions like New Year party, Christmas celebrations, your birthday celebrations. You have uploaded these pictures to photo apps like Google Photos, or you want to arrange these photos based on themes. All you need to do is label a few photos with the names of your family members. The photo app figures out who is in the picture and automatically group photos of the same person. Some applications of semi-supervised in healthcare. Semi-supervised learning is used in medical analysis to diagnose a disease where there is limited labeled data during initial phase of disease and large amount of unlabeled data. Next slide. Next type of hybrid learning and machine learning is self-supervised learning. SSL is the short form for self-supervised learning. Self-supervised learning is a hybrid type of machine learning in which the algorithm learns patterns from unlabeled data by generating supervisory signals from the data itself. Self-supervised learning is used in computer vision and natural language processing (NLP) applications. In computer vision, self-supervised learning, instead of relying on labels, it leverages the structure within the images to distinguish between different images, identifying the specific changes in the images. SSL performs pretext tasks that allow model to learn patterns from raw data without need for explicit data labeling. Pretext understands the spatial and semantic structure of the data. SSL can learn different positions of patches in an image, help model to understand the surrounding context, missing context parts in image or text like jigsaw puzzle. Let us look at some examples. If you rotate some images by 90 degree, 180, 270 degree, SSL can learn the rotation angle. When set of images are rotated at random, SSL can predict the angle by which images are rotated, whether image is rotated at 90 degree or 180 degree or any other angle. Another example. In an image, some portion of the image is missing. In this image with cake, candles are missing. SSL can predict the missing part and complete the image. Next slide. Hybrid learning approaches. Does hybrid learning improve ML performance? If yes, then how does hybrid learning improves ML model performance? Unlabeled data is almost readily available and is plentiful. But labeled data is not readily available and it is limited. Hybrid learning makes effective use of both labeled and unlabeled dataset. Hence, hybrid learnings improve ML performance. Problems faced in natural language processing (NLP) while processing text data. Problems faced while processing image data in fields of computer vision cannot be easily solved by learnings from supervised and unsupervised. There comes hybrid learning that improves machine learning model performance. Semi-supervised learning focuses on how to group examples in representation like clusters. In semi-supervised learning, first step is to identify groups or similar clusters from unlabeled dataset. Once similar clusters are identified, then supervised learning methods are applied to label the unlabeled dataset. Semi-supervised learning explores the data and improves accuracy of supervised learning by exploiting information in unlabeled data. Similarly, self-supervised learning creates pretexts that rely on data's internal structure or transformations to generate pseudo-labels. Pretext tasks include rotation prediction, jigsaw puzzles, and predicting masked parts of an input image or input text. Next slide. Let us compare supervised learning, semi and self-supervised learning in terms of effort, time, cost, and prediction accuracy. Supervised learning uses labeled data types. Supervised learning is time consuming as the data need to be labeled manually or by using AI tools. As the data needs to be labeled by human resource or by AI tools, supervised learning is expensive. As the data is labeled, the predictions are highly accurate unless there is some manual error while labeling the data. In short, supervised learning takes less processing time as the data is labeled, but labeling itself may be time consuming. Supervised learning provides accurate predictions. Next, unsupervised learning uses unlabeled data. There is not much effort to label the data. Expect to identify the categories or clusters. Unsupervised learning is less expensive, less time consuming as no need to label data. Unsupervised learning has low accuracy compared to other machine learning algorithms. Unsupervised learning may have noise in data and it may lack clarity in clusters. Semi-supervised learning uses both labeled and unlabeled data. In terms of effort, time, moderate to high, less cost compared to supervised learning. Provides good accuracy in medical fields where there is limited data at initial stage to diagnose a disease, as we saw in previous slides, COVID-19 example. Self-supervised learning works on unlabeled data or raw data using pretext. In terms of effort, moderate to high. In terms of cost, less expensive than supervised learning. Provides high accurate results in computer vision and natural language processing tasks where the part of the image or the text is masked or transformed. Let us recap the learnings of ML in the next slide. First question. Which type of machine learning is used in recommendation system? Like recommending a Netflix movie or so. Is it supervised or unsupervised? Second question. Which of these learnings are hybrid and uses pretext? Option A. Supervised learning. B. Semi-supervised learning. C. Self-supervised learning. D. Unsupervised learning. Let us look at the answers. Which type of machine learning is used in recommendation system? Like recommending a Netflix movie or so. Is it supervised or unsupervised? Recommendation systems use both supervised and unsupervised learning. If the objective is to identify the patterns or clusters of similar users, then unsupervised learning is used. If the use case is about recommending products based on user preferences, rating, clicks, then it is recommendation system based on supervised learning. If the goal is to predict user preference, then use supervised learning. So both supervised and unsupervised learnings are used in recommendation system depending on the requirements. Second question. Self-supervised learning is hybrid learning and uses pretext. Hence answer is option C. This brings us to the end of this video. I hope you like this video. Please like, share and subscribe to the channel and let me know your comments. Thank you for watching. See you in the next video. Until then, happy learning.